jumping spiders that build orb webs, snow leopards, and tigers from Russia and India made the headlines last week, as did the impact that climate change has on the lives of Indian fishermen. And finally, a fertilizer made out of biomolecules that is much safer than chemical fertilizers. Let's talk about all this and more. I'm Annie, and this is Research Bytes, your dose of science news. A jumping spider is a master hunter with large eyes and the ability to leap vast distances. They belong to the family Celticidae, and it's arguably the cutest spider family. Their ability to pounce and capture their prey makes them textbook examples of active hunters. This active hunting lifestyle is no easy task, and even a spider needs a little rest. But unlike most spiders, these don't build webs to catch their prey. They do, however, build nocturnal shelters, a silken home they can use to retreat to at night. The nocturnal retreats of Celticids are as diverse as the spiders themselves. Jumpers from the Anesmonia species build a thin sheet out of silk under leaves, while others like Hylas and Telemonia build a silk platform between leaves. The weaver ant mimicking spider, Myrmeracne, builds elaborate tubular shelters with multiple entrances. But in contrast to all of these is An Arotis, a jumper from the family Celticidae that weaves an orb web as its nocturnal home. Building orb webs is a characteristic of another family of spiders, the Erinidae. They use their orb webs to catch prey, but An Arotis uses its orb web only as a nocturnal retreat and not to catch prey. There are only a few ways that a spider can efficiently build a web of this kind, and the similarities between the orb web of a Celticid jumper and an Erinid spider could reflect how these two families use the same approach to solve a common problem: escaping from hungry nocturnal predators. When suspended on its web, An Arotis may be alerted of a would-be predator by the vibrations that would get transmitted to the hub of the web along the silken threads. The orb web of the Celticid is also used as a molting sac. This is a safe place for the spider to shed its old exoskeleton. The researchers saw An Arotis molt while hanging from a silken thread in the web called a dragline. It took advantage of gravity and lowered itself along the dragline, shedding its old exoskeleton. This molting behavior is similar to that of many wandering and web-building spiders from different families. Although molting is linked with mating in some orb-weaving spiders, not much is really known about this jumper's courtship and mating behavior. Since most jumping spiders build a protective sac for their young ones, this poses the question of how An Arotis may protect its brood. The researchers speculate that this jumper might still make a protective sac for its spiderlings, like most wandering and web-building spiders do. So the next time you're in your garden, maybe take a closer look at all the creepy crawlies, and you may learn a thing or two about them. Tiger, tiger burning bright in the forest of the night, what immortal hand or eye could frame thy fearful symmetry? This poem by William Blake captures the majesty of the Maharaja of the forest. This big cat is now endangered, but it once called much of the South, Southeast and Central Asia its home. Today, there are 2 recognized subspecies of tiger and 9 geographical populations in a few wild havens within their historical range. Their numbers have dwindled over the years, with roughly 3,890 of them still roaming the wild. Their populations in these locations face different environmental stresses, but there are very few studies that have analyzed data across these multiple tiger populations. In one study of this kind, researchers compared the chemical contents of the fecal matter of the Amur and Bengal tigers. They did this to understand the kind of stress levels that these tigers deal with. Amur or Siberian tigers are found in the eastern parts of Russia, while the Bengal tigers are found across the Indian subcontinent. The study investigates the difference in the concentration of fecal glucocorticoid metabolites of the two tiger populations. Fecal glucocorticoids show us how well an animal is faring. Lower levels of this in the fecal matter mean fewer negative stressors in the animal's environment. When researchers study wild animals, they prefer to collect the samples quickly without disturbing them. In this study, the researchers tried to identify the best protocol for analyzing fecal samples using 3 different methods. In the first, they used wet fecal samples directly from the field without any manipulation, while the other 2 methods used dry fecal matter. The results showed that testing wet fecal matter recorded the highest concentrations of fecal glucocorticoids, followed by methanol, ethanol, and boiling methods for dry samples. Among the Indian tigers, those in the Kanha reserve had the highest levels of fecal glucocorticoids, followed by those in Bandhavgarh and Sariskar reserves. But these differences were not significant. When compared to their Russian counterparts, the researchers found that Indian tigers have a 20% higher fecal glucocorticoid level, which indicates higher stress. And what could be stressing out our Indian tigers? Well, their territories in the Indian jungles are quite small. To add to this, about 300 to 500 tourists visit these jungles every day to sneak a peek at these cats, and this could further stress them out. This highlights the need for better tourism management in our national parks, which takes the welfare of our animals into consideration as well. The elusive snow leopards, Panthera uncium, are found in the rugged and remote mountains of Central and South Asia. Today, they are fighting for their survival against the odds of climate change, dwindling prey populations, habitat fragmentation, poaching, and attacks from feral dogs. As apex predators, they sit on the top of the food chain in these high-altitude ecosystems. They are a flagship species here, and conserving them could ensure the protection of the entire ecosystem. Aptly called the ghosts of the mountain, the snow leopard is not easy to spot. Today, somewhere between 500 and 700 of them take up residence in the Indian Himalayas. In this first-of-its-kind study, researchers used data from direct observations and camera traps to model the conditions for a suitable habitat for the snow leopards in Ladakh. Ladakh is known as the snow leopard capital of the world and is thought to harbor 60% of India's snow leopard population. Searching for these coy cats in the mountains is like looking for a needle in a haystack. It is extremely difficult to spot one in the vast mountainous terrain. But these predators do not shy away from troubling farmers in the region. And this has resulted in the farmers being uneasy with the idea of conserving them. The snow leopards tend to kill their livestock in pens at night, and this makes the farmers angry. So it's become challenging to gain the people's support, and without it, it's almost impossible to conserve this species. The researchers used computer-based models to understand what kind of habitat parameters suit these snow leopards the best and would minimize their conflict with humans. They recorded the ruggedness of the terrain, its elevation, the distance to the nearest water source, the distribution of the cat's favorite prey, the Asiatic ibex and the blue sheep, and the land cover at these locations. The study found that the elevation of the habitat was the most influential factor in determining its sustainability for the snow leopards. An ideal habitat would have an elevation range between 2,800 meters to 4,600 meters, with a ruggedness between 450 meters to 1,800 meters, and a water source in the range of about a kilometer. As open herbaceous vegetation makes it easier for these cats to find their prey, land cover is preferable. So based on these metrics, the study found that only a third of the landscape in Ladakh is suitable for the leopards to thrive. And with lakhs of tourists flocking these mountains each year, the region has seen many homestays mushrooming to cater to this demand. So can this development lead to more human snow leopard encounters? The study found that a majority of these homestays are in areas that are suitable for snow leopards, and the cats frequent them to hunt livestock. And what could we do to minimize this conflict? The researchers say building predator-proof corrals and keeping a check on tourism in these areas is a big plus point. Predator-proofed corrals have already borne fruit in the past, and there has been a decline in the number of livestock that have been killed by snow leopards in the recent years, even though the cats still frequent the villages. The researchers also saw a phenomenal shift in the people's attitude towards the snow leopards as they attracted more tourists and brought more tourism revenues to these areas. And so, agencies like the Snow Leopard Conservancy India Trust and Panthera have been able to change a threat into an opportunity by starting homestays and snow leopard tourism. Today, the farmers consider the snow leopards worth more alive than dead. This step could play a key role in involving local communities in conservation efforts. In 2018, the snow leopards made a historical leap in their status from endangered to vulnerable on the IUCN's Red List of Threatened Species. But on the contrary, there is not much action on the ground when it comes to conservation of snow leopards and other wild animals in the mountains. And in this absence of continued scientific and community-based conservation efforts, it will just be a matter of time before these majestic cats indeed turn into ghosts and go extinct in the wild. India's agricultural yield has seen a steady increase over the years, and this is thanks to the use of chemical fertilizers. But their reckless overuse has resulted in the severe degradation of the environment and economic losses to farmers as these fertilizers run off with water and are unavailable to the crops. A recent study has developed a biomolecule-based fertilizer that can help address the drawbacks of chemical fertilizers. Many species of bacteria, fungi, and algae act as natural fertilizers, and they increase the soil nutrients and make it readily available for plants to absorb. And since they have a biological origin, these biofertilizers don't harm the plants or the environment. Rhizobacteria is one such biofertilizer, and it lives in the roots of plants and helps their growth. It secretes biomolecules which act as signals for communication among the bacteria that live in the roots of these plants. They don't just regulate the plant's growth, they also increase a plant's ability to withstand diseases. But on the flip side, these biomolecules are unstable in the soil and they quickly degrade, becoming unavailable to the plants. So the researchers developed a stable substrate using iron-carbon nanofibers to help deliver these biomolecules to the plant. This combination of the substrate and the biomolecules was super effective for the plant's growth and its ability to fight infections. The study found a massive 116% increase per day in the germination rate of seeds and almost a 4-fold increase in the length of the seedlings that were grown using this biocompost. They also saw this increase when the plants were subjected to oxidative stress and salinity. So how did this biocomposite work? And so how did this biocomposite increase the plant's growth? Well, it helped increase the moisture that is carried from the root to the pores in the leaves where it's released as water vapor. This increased a process called transpiration which then resulted in an increase in chlorophyll and protein contents in the plant. This increase of chlorophyll helped increase the photosynthetic activity of the plant. And so the study showed that this biocomposite could be much more successful and could possibly replace chemical fertilizers. The researchers estimated that the production cost of the biocomposite could be 10 times less than that of chemical fertilizers. And it only takes a small amount of the biocomposite applied just once for a good yield, while chemical fertilizers needed to be used at least thrice in the life cycle of the plant. And the icing on the cake is that this biocomposite is organic in nature and doesn't pose any threats to the environment or to the plants. Climate change, the extreme weather that it then causes, and the rising pollution of our seas has been causing a steady decline in fish populations. And if this continues, you may not only miss your favorite seafood, but it could affect the livelihoods of thousands of fisherfolk. So how do these fishermen cope with climate change and the resulting challenges? In a series of studies, researchers shed some light on the strategies that they adopt to maintain their fish catch and income. They looked at how they responded to weather warnings, including the factors that affected these decisions. India has 3,288 marine fishing villages in 9 coastal states and 2 union territories. So understanding the dynamics of the fishing community won't just help secure the livelihoods of thousands, but will also help frame policies for their betterment. The researchers collected this data from previous studies on fisherfolk communities, exploratory fieldwork, focus group discussions, and a household survey of 601 fisherfolk from fishing regions in Maharashtra. The researchers saw that rural fishing communities had strong social bonds and they were more likely to circulate risk-related information that helped avoid the loss of life. While urban fishermen adapted to climate change by shifting to mechanized boats. The fisherfolk used better fishing gear, worked extended hours, fished farther into the sea, and pursued other jobs to complement their livelihoods. A good education, savings, perceptions about change, and the risks that affected their livelihoods and even pollution played an important role in shaping how they dealt with climate change. An education gave them access to information on fishing, boat insurance, and mechanized boats. Subsidy and credit schemes by public institutions helped support these fishing communities. The fishermen were affected firsthand by marine pollution. They would see plastic waste, oil spills, sewage from nearby cities, and effluents from industries in the oceans and seas. Sharp and solid debris harmed their fishing gear and nets, and pollution influenced the kinds of nets and boats that they chose to use. Extreme weather, like torrential rain and storms, posed a higher risk to fishing communities as they ventured into the sea. And adhering to weather warnings became key to saving lives. Factors like their experience of storms and cyclones, the type of boat and its insurance, indigenous knowledge and societal trust, and even local government authorities helped influence how they dealt with extreme climates. Young fishermen, or those that had experienced extreme weather events, heeded weather warnings for their safety, whereas fishermen with years of fishing under their belt, or those that used mechanized boats, didn't usually follow weather warnings. The researchers speculated that warning information that included traditional weather knowledge might make it more familiar and reliable to the fishermen, and they would be more likely to heed it. So, how could we educate our fisherfolk? Awareness programs to help the community understand the increase in extreme weather events and the importance of heeding these warnings is key. But in addition to this, we need to reduce the trust gap between communities and information providers through personal interactions and workshops. In the long run, education will help fisherfolk to adapt their decisions and provide them with opportunities to choose different livelihoods. Thank you for tuning in. I hope you enjoyed this podcast. Links to all my references can be found in the description below. And for more science-based stories, podcasts, and news, log on to our website www.researchmatters.in.